My name is Rupesh. I am a research scholar at the Department of Electronics and Communication Engineering at PS University, Ring Road campus. I will be giving a brief overview of the paper Outage Performance of Relay Assisted Single and Dual Stage NOMA over Powerline Communications. To begin with, let's see the advantages and working principle of NOMA. NOMA exploits the power domain multiplexing, which allows the user to be served with the same resources such as frequency, time, and code. Power is allocated to each user based on the channel conditions, that is, users with better channel conditions are allocated with less power. Power allocation plays an important role in the capacity enhancement. Now, let's look at the working principle of NOMA. NOMA employs the superposition coding at the transmitter and signal interference cancellation at the receiver to distinguish between users. A superimposed signal is sent from source to the receiver. Receiver 1 performs SIC and obtains the signal which is intended to it. Similarly, receiver 2 decodes the signal which is intended to it. Moving on, let's look at how the signal interference cancellation works. The first signal decoded by SIC is the highest, while the others are considered to be interference. The received signal is deducted from the first decoded signal, and if the decoding is ideal, first the wave shape with the rest of the signal is correctly obtained. Next, let's look at the single and dual stage NOMA over powerline communication. In single stage NOMA, the source sends the superimposed signal to both the relay as well as the destination. Relay decodes the signal S2 using SIC and S1 directly, and in the first time slot, the destination decodes the signal S1 directly. Whether the signal was decoded properly by the relay or not, it has two conditions. So, whereas the relay sends the signal S2 to the destination based on the following condition. In the dual stage NOMA, the source sends the superimposed signal to both the relay as well as destination. The relay obtains the signal S2 by using SIC and S1 directly. Here the destination does not decode the signal in the first time slot itself. Now the relay sends the superimposed signal to the destination in the second time slot. Then the destination jointly decodes the two symbols with equal gain combining. Let's look at the results. The result shows the variation of the optimal outage probabilities with the SNR for different end-to-end distances, and the perfect match between the analytical and simulations shows the tightness of the approximations made. Similarly, for the dual stage also, the result shows the variation of the optimal outage probability with SNR for different end-to-end distances. In comparison, the dual stage outperforms the single stage, that is, the SNR required for the dual stage NOMA to achieve a given outage probability will be considerably lower compared to that of the single stage NOMA.